The concept of mathematics we have chosen to do for this vodcast is derivatives. Derivatives are used and applied in many social sciences such as business and economics. Derivatives allow professionals such as economists and business analysts make the right decisions of, example, production in order for a firm to maximize a profit and minimize their costs.
Derivatives lie at the core of calculus, which is an important aspect of modern mathematics. The derivative can be explained as the rate of change or slope of a curve, and it helps us determine a point on the function. The derivative also aids in finding minima and maxima points, which helps business and analysis know what their profit maximizing and cost minimizing profit or points are.
The revenue function is used to calculate the revenue received by a firm, that is, the price of the good times the quantity. The derivative of R of X is R prime X, and it is called the marginal revenue, MR, which is used to measure the rate of increase in revenue per unit increase in sales. For example, if marginal revenue, R prime X, equals price, then the price is constant, suggesting it is in a perfectly competitive market. The curve of the revenue appears to be a downward-looking parabola, and in order to find the profit maximizing values, if R of X equals 10x minus 0.05x squared, then the derivative of that, MR, R prime X equals 10 minus 0.1x, which is then x equals 2000, which is the stationary point and maxima of the parabola, which is the the revenue maximizing point. And then you substitute this value into the revenue function, R of X, in order to find the value of Y.
Cost function in economic expressing production cost in terms of amount produced. In mathematical optimization, cost function need to be minimized. In cost functions include two costs, a variable cost and fixed cost. Fixed costs are cost business expense that are not related to level of goods or service produced, such as salary and rents. Variable costs, which are paid per quantity produced. For example, we have a cost function like 0.005x squared minus 5x plus 1000. So in this example, we can see that 1000 is assumed as fixed cost and variable cost is 0.005x squared minus 5x. X is a quantity of goods produced. To find the marginal cost, we derivate the cost function. After that, we got the answer is 0.01 x minus 5. We get the first derivation test equals 0. Then we got x is 500 and replace 500 into the cost function. You got minus 250. This point we need to find out that's the maximum point or the minimum point. Then we do the second derivation test. We got 0.01. 0.01 is larger than 0, so we have the conclusion that this is the minimum point. Following these informations, we draw the graph, and we can see that in the cost function, the minimum point when x is 500 and the cost is minus 250.
As a business's main goal is to generate profit, profit is seen as a very important factor. Therefore, its analysis is necessary in order for one to provide predictions, evaluations, and understandings of the results caused by management's decisions. It is determined by the profit function, P in terms of X, X being the output level. The product function can be found if the revenue function is minused with the cost function. Therefore, P of x equals R of x minus C of x. In terms of the values previously mentioned, P of x equals 10x minus 0.05x squared minus 0.005x squared minus 5x plus 1000. Therefore, by simplifying this equation, you get minus 0.055x squared plus 15x minus 1000. Therefore, by deriving this profit function, one is able to find the marginal cost. By deriving the previous equation, it equals minus 0.11x plus 15. This provides a visual representation from the slope provided, therefore allowing one to evaluate the production levels. Furthermore, if the derivative of profit is equal to 0, one is able to find a maxima, hence finding the profit maximization point. Through all this evaluation, a firm and its management is able to predict and evaluate the effectiveness of their current decisions and its profitability. In conclusion, the derivatives of the three functions, which are the revenue function, cost function, and profit function, one is able to determine the marginal corresponding values of each function, therefore allowing the slope to be determined, and by graphing these slopes, one is able to evaluate and predict how much it's going to cost for an extra unit to be produced. Therefore, this mathematical principle is being utilized within the everyday business environment, hence showing the value and importance of this maths principle.